Good day, everyone. Today we're excited to present our microcontroller project, the Tea Dipper. This project was developed by our team, Group 14, from Section 11 of the Microcontroller and Applications course. The Tea Dipper is a solution to a common problem many enthusiasts face. Now, before we talk about the details, let's go over what we'll be covering today. We'll start with an introduction to our project, explaining the concept behind it and the components we used. We'll then show you the circuit diagram and the code to our Tea Dipper. After a demonstration, we'll discuss the credits for our inspiration and resources and highlight our own contributions to this project. Now, have you ever made a cup of tea and forgotten about it until it became too bitter? Or removed the tea bag too early, resulting in a weak flavor? Tea bag timing can be particularly challenging for newcomers to tea brewing. Even if the timing is off, you end up with either a bland or bitter tea that doesn't deliver the perfect flavor. Our project aims to solve this problem by helping users achieve the ideal tea taste through precise timing and automation.
And for the another utility for our project, since our project can list the tea bag automatically, user has no longer need to wait and can go to do some other tasks, but still can have good tea. And if the user forget they are still boiling the tea, our project have the alarm function to warn the user that their tea are finished.
So what exactly is our Tea Dipper? Our Tea Dipper is a machine that automates the tea brewing process by dipping a tea bag into a cup of hot water, then lifting it out after a predetermined amount of time. This ensures consistent results and helps users achieve a better tea taste with appropriate timing. The device eliminates the need to watch the clock or remember to remove the tea bag, making the brewing process more convenient and reliable. Now, let's look at our components. Aside from the in-box components such as wires, resistors, switches, Arduino boards, our Tea Dipper is built with simple components. We use wooden sheets as the structural base for our machine, providing stability and aesthetically pleasing appearance. A servo motor provides the mechanical movement to dip and lift the tea bag. Also, we have included a passive buzzer to provide audio feedback, or in our case, to play the music when the brewing process is complete, alerting the user that their perfectly brewed tea is ready. Now, here is our circuit diagram for the dipper. As you can see, we have connected the Arduino board to our breadboard, which helps organize our connections. The passive buzzer is connected to provide audio alerts. We are using two servo motors, one for the tea bag handling and another for rotation. The circuit is relatively straightforward but effective. Our components are properly connected to ensure smooth operation of our tea brewing automation system.
And this is the inner line circuit that we use the wooden sheet to be the base for the servos and connect them to Arduino by the breadboard. Okay, for the code section, the first we will include the library we will use to control the servo and define which pin we will connect the buzzers. And we will define the frequency we will use in the buzzers by the name of the nodes we will use in this project. And we will set the state variable to 0 that are the starting state and define the servo's name T and rotate. The servo name T is a servo that will pull T back up and down, and the rotate is the servo that will move the T back from side to side. The T angle and the rotate angle variable is the starting angle for the. And for the boolean stop song, we will set it to false, and we will use it later when we want to stop the song from the buzzers. And bit length is the default length for each node we will use in this project. And bit separating constant, we will use it to make the gap between node to node. We will define the nodes we will use in the song and the duration in the song 1 chorus melody and song 1 chorus rhythm array. In the setup, we will define the pin 5, 6 and 7 to be the input, and we will define the pin we will attach to the T servo and the rotate servo and set the starting angle. And then we will announce the interrupt that we will use in this project, and we'll go next to the loop section. In the loop section, we will use if and else to define the current state in the system. If the state is equal to 0, the T servo and the rotate servo will move to the starting location and wait the user to press the start button. In the state 1, the T servo will drop the T back and wait it to 3 minutes. We will use the while loop to make this delay 3 minutes because we want the system can go out from this delay at any time. If we press the start button again, the state will change back to state 0, and if we wait to 3 minutes, the state will change to state 2. In the state 2, the T servo will pull up the T back again, and the rotate servo will move the T back to the left to make the user can pull up the cup of tea easier. And when everything is done, the system will call the function play chorus to make the buzzer play the song to warn the user that the tea is ready. And for the function smooth servo move, we use them to make the servo move slowly. As you can see, in our project we use this function all the time because we don't want the servo move too fast. That will make the T back to speed the T all up. When we call the smooth servo move function, we have to define which servos we will use, the starting angle and the destination angle, and the delay time. When we call it, they will move the servos from the starting angle to the destination angle by 1 degree every the delay time we define. In the play chorus function, we will make the buzzers make a noise by using the for loop to assign the frequencies and the duration we store in the array to the buzzer. And when the note is played, we will delay the system by the duration that are the beat length multiplied by the note rhythm, and we will stop the buzzers by note tone and delay the next note by duration multiplied by beat split constant. And the last part is the ISR that we will use when the system receives the interrupt signal from the button. It will change the state to 0 when receive the signal from the pin 5, go to state 1 when receive from the pin 6, and make the stop song variable to 2 to stop the song from the buzzer, and go to state 3 to stop any progress in the system when received from the pin 7. Okay, for the demonstration, we will show the flow to use our project. First, tie up the tea bag and put the cup like this, and when everything is done, we will press the start button to make the servo put the tea bag down. Normally, we have to wait 3 minutes, but for the demonstration, we set the delay to 10 seconds. And when the delay is done, the servo will pull up the tea bag and put it to the left, and if you want to stop the music, we will press the button to make the servo to make the buzzer stop. And when we want the object to go to the starting state, we will press the button to move the servo back to the starting location. And this is all. for the demonstration.
Now, I'd like to highlight our contributions to specific highlights to this project. We focus on two main areas, the servo movements and music implementation. For the servo movements, we developed a smooth control system that gently lowers the bag into the cup and lifts it out when the brewing is complete. This required careful programming to ensure the movements were precise and reliable. As for the music feature, we implemented a melody that plays when the brewing is complete, adding a fun touch to the user experience and serving as an audio notification when the tea is ready. Now, we'd like to acknowledge our source of inspiration and assistance for this project. The initial inspiration came from an Instagram reel that showed a similar concept. The musical component uses a melody from Rick Astley's Never Gonna Give You Up, with code adapted from my project on the Arduino Project Hub. We also used a ChatGPT to help refine some aspects of our code, which was particularly helpful for optimizing the servo movement sequences and troubleshooting integration issues between components. Now, thank you for your attention. We hope you have enjoyed learning about our Tea Dipper project. We believe it demonstrates how microcontrollers can be used to help solve everyday problems in creative ways. We are now happy to answer any questions, if there is any, about our design decisions, the implementation process, or potential improvement for future iterations. And here are the members, Sarun Prasert and me, Pongsatorn Salwala. Thank you.